Hello, everybody. My name is Itamar. I'm from the R&D team of Netafim, and today I'm going to talk about potential for variable rate fertigation in vineyards with variable rate drip irrigation. So let's talk about diversity and variability for a second. So we live in a very diverse population where everybody wants to be unique and special and only me, and some of us like long hair or short hair or that kind of t-shirt or that kind of t-shirt, and it's okay because it's a society and diversity is welcomed. But when it comes to agriculture, we want everything to be the same, especially in vineyards. We want that every vine will look exactly like the one next to him to give the same quality of yield and the same quantity, so we'll get the perfect wine that we have. So in this occasion, the rainbow is colored only with black. This is what we want to achieve. And then comes reality. And in reality, not everything is shiny and everything is equal. We have a lot of variability, as you can see here in this vineyard from Bavaria, Germany. And in this small plot of vineyard, you can see areas with good vegetation and probably high yield. And on the other side, we have areas with low vegetation and low yield. And I guess that the quality will be different. So again, we have a very colorful rainbow with different types of vines and different vegetation. So let's talk about variability. So we have different causes for variability, and on one side we have causes for water-related variability, like slope plots, like you seen in the image before, different types of soil in the same plot, soil depths and other, but all related to available water. And on the other side, we have some causes for chemical variability, like again, different types of soils, organic matter variability, pH, salinity, and other issues that related to available nutrients. And the two of them, the available nutrients and water, derives the variability that we actually see in the plot. So let's talk about irrigation for a second. We all know that we need to adjust our irrigation, especially the irrigation scheduling, according to the soil type. So if we have a clay soil, that means that the intervals between irrigation can be longer because the water holding capacity of the soil is much larger than in sandy soil, where we need to irrigate much more frequent. So we can look on what kind of soil we have in the plot and then to decide on the irrigation scheduling. But what happens if we have a plot like that, when you can clearly see that there are a lot of soil types, probably different soil depth, and how we can schedule our irrigation according to that? So if we'll take that plot and we'll irrigate it by a same irrigation frequency, the result will look probably something like that. And this is a vineyard from California, and you can clearly see that it's highly variable with areas with high vegetation and areas with low vegetation. And it's because everything is irrigated the same and not according to soil type, because you just can't do it. So if we are talking about variability and variable soil and variable vegetation, maybe in order to make it complete and full circle, maybe we need to think about variable irrigation and also variable nutrition to complete each other. So variable rate application is not something new. It's available today. You can take your plot and just to divide it to several management zones, and in each one of the management zones, we can apply different amount of fertilizers or pesticide or even tillage and even irrigation. So it's not something new. But the problem here is that most of the technology available today for variable rate application is mostly for open fields and not for orchards. And this is the advantage for us in this case. So now I'm going to show you a little bit about a system that we developed, a variable rate drip irrigation that we are developed in order to irrigate vineyards and generally orchards in a variable way. So we had a pilot in a vineyard, 2006 Syrah variety vineyard in Israel, 1.2 hectare, highly variable in vegetation, yield, and quality. And what we found is that at the north part we saw low vegetation and low yield, and in the south of the plot we saw high vegetation and high yield. And as you can see, it's not a big plot, it's only 200 meters from end to end. And if we're looking on the NDVI map of this plot, you can clearly see the pattern that we saw of high vegetation in the north and low vegetation in the north and high vegetation in the south. So the problem that we have is variability, and we are very limited because we have only one irrigation zone. And the solution that we found for this variability is the VRDI system, variable rate drip irrigation. So we actually took this plot and we divided it into 12 irrigation zones or irrigation pixels, where each pixel is 30 by 30 meter um, area, and each pixel can be independently irrigated with different amount of water, different timing. It's like a completely new irrigation system, which gives you a much better resolution and flexibility with the irrigation of the plot. And because it's much more complicated system, we had a much more complicated irrigation model. So this is the general irrigation model. I won't go into deeply into it, but in order to decide how much to irrigate in each one of the pixels, we are using remote sensing, mostly NDVI. We can use also thermal imaging as a replacement for stem water potential. And the result of this model is that we can decide how much and when to irrigate each one of these pixels, where the target, the goal is to achieve uniformity. So the experiment went over 4 years, where in the first year in 2014, it was just a control. We just did a lot of measurements, and it was irrigated by the farmer as usual with only one zone of irrigation. Then in 2016 and 17, we applied and operated the VRDI system with the 12 zone. And in 2018, we shut down the system and gave the irrigation back to the farmer to his own practice. So here on this graph, you can actually see the different irrigations. I will put my pointer for a second. You can see the different irrigations at the different pixels from A1 to A6, and you can see that some of the pixels got more water early in the season and other got less water than the others. And this is all about the variable rate. And at the end of the season, we got actually different amount of water applied in different areas of the plot comparing to the farmer baseline in the dashed red light that you can see. So this is all about variable rate irrigation. Give more water where it's needed and less water where it's not needed. And I just will show you some results. So this is the yield results from the uniform irrigation, the control in 2014. And you can see clearly the reduction of yield from south to north, where the vegetation was lower at the north, so the yield was much lower. But when we applied the variable rate irrigation in 2016, you can see that there is much more uniformity in the plot. You still have some variability within the plot, but you don't see the same trend of reduction of yield from south to north. It was also in 2017, but I'm not showing it here. And most interesting is in 2018, when we shut down the system, all the variability just appeared back. So you can see also the trend here of reduction in the yield in the north part, very similar to what happened just 4 years ago. Again, it was the same irrigation in 2014 and 18 by the farmer with only one irrigation zone. So this is the advantage regarding the irrigation. So let's go back now to nutrition. So in this plot, you can see this leaf, and this leaf is for certain under some kind of nutrient deficiency. And it could be a deficiency of probably some micronutrient, maybe iron or magnesium, something else. And usually when we see this deficiency, what we do is we go to the field, we identify the deficiency, we take some leaves and some samples, we send it to lab test, we get the results, we get the recommendations, and then we go and do the application of the fertilizers, and we usually applied it to the entire plot. But what happens if on one hand of the one side of the plot we have this vine that you can clearly see that suffers from some kind of nutrient deficiency, and on the other side of the plot, just 100 meters away from there, and it's the same row, same variety, same irrigation, same everything, the vine looks completely different. It doesn't suffer from any nutrient deficiency. So here comes the question: why to apply so much fertilizers to the entire plot when it's not needed to the entire plot? So this is the potential and place that variable rate nutrition can come to assist. So if we'll take the same plot that I was talking about before with the 12 irrigation pixels, now we can actually apply different amount of fertilizers to each one of those pixels and not the same to the entire plot as before. So we can actually give more nutrient, that nutrient or other nutrient using the irrigation system to different parts of the plot, and also in different timing. We don't need to give it in the same time to all the plots. We can spread it across the season, and we can apply much more in the north than in the south. So the flexibility here is much more higher than in a regular system. But not all is very nice and shiny. We still have a lot of challenges to go before we apply variable rate fertigation. And first of all, it's the detection. So we need to actually identify where and what is the nutrient deficiency. So one possibility is just to take a lot of people and send them to the plot and do some grid tissue sampling, but it's probably more expensive than the saving of the nutrients. Another option is to take remote sensing from satellites, but the resolution is not good enough, especially if we're talking about micro nutrients. Maybe for nitrogen it's okay, but not for micro. Probably, and the best we can do with high resolution imaging, which could be optional, and in the long term it could be cost effective. Another issue that we have is then the prescription. So how can we know what to apply? We need to know what to apply. We need to know how much to apply from each fertilizers that we identify and detect before. And once we know these two questions, now we have another two questions: when to apply it and where to apply it, because now we have much more flexibility about where to apply the fertilizers. And once we decide that, now we can go to the application. So we can apply variable rate with foliar application like you see in the image below, and there are some solution for that. We can apply it with granular application if this fertilizer is available in a granular form. And we can also use the variable rate drip irrigation system to apply different amount of fertilizers in different timing. So to conclude, so according to our experiments, the VRDI system has increased the total yield in the vineyard whenever the system was operating. And the system has clearly reduced the variability in the plot, and we got the same yield across the entire plot, and it's very important. And most interesting is that once we shut down the system, all the variability appeared back. So it's not a matter of a silver bullet and one shot. You need to keep applying the variable rate irrigation constantly in order to get good results. And also the VRDI system can be used for variable rate fertigation in vineyards and in general in other orchards, and it's a good potential, but still we need to further do some R&D activity about the deficiency detection, because it's very crucial to be very specific about it and very accurate about it. So again, thank you very much for inviting me to talk about this topic, and I would love to answer your questions. And if you have another questions after that, you can approach me with the mail below. Thank you very much.